Day 12. What's going on? So we have a grid of letters or something. Let's see. What are we doing? Price the area by the perimeter. Okay. Um, um, that is a number. 519 is 1. Uh, zero is right, I believe. Uh, the number of sides. The area by number of sides. Okay. Um, how do I compute the number of sides? How do I compute the number of sides? This is like that even true? They're like the connected components of, I don't know, probably. Uh, 100 does not look very correct. Uh, what, we have still 100. Seven 36. Still wrong. Okay. The downsides. One, two. Right sides should be 3. 6. Yeah, okay. 26. Pretty good. Even though that was, pretty slow. Okay, so too slow in part 1, but did pretty well in part 2, even though it took me what felt like ages. But it was kind of tricky, so I guess it took everyone else ages too. Okay, so what's going on here? Sorry about all the coughing. So we're given this grid of letters, and we should consider regions. Like here's a region. Well, I can't highlight it well, but there's some region of like ortho-connected R's, right? That is R's connected by up, left, right, or down. And we want to consider all these regions. And in part 1, we want to find the area of the region times the perimeter of the region. So the perimeter is, all the sides on the boundary of of the region, including off the edge of the board, which I wasn't sure about initially. Um, yeah, let me modify this to also compute part 1. Uh, so that prints out 1421958 and 885394. Good. Okay. Uh, Sorry. So we're going to go through the grid. Right, so first we parse it as a grid, including getting the number of rows and columns. Then we go through the grid and calculate the regions. So if we see a square that we haven't visited before, that will introduce a new region. So we're going to do a BFS to figure out the region. We're going to compute its area and perimeter, and we're also going to compute this other thing, which is going to let me calculate the number of sides, which I'll explain in a bit. Not required for part 1. And then we just do a BFS. So grab a square from the queue. If we've already seen it, skip it. Otherwise, say that we've seen it, add it to the area. I think area is just len of seen. And then for the 4 directions, I decided to define this up front today in case I needed it, which I did. This is like, you know, the delta in the row and column for up, right, down, and left. So figure out a new square. And if that square is in bounds and in our region, then we add, add it to the queue. It's part of our region. Otherwise, it counts towards the perimeter, right? You can think of the perimeter as just exactly those edges that we can't cross, right? Because that means that there's a side, like where our region ends, which is what the perimeter is. And then we're also going to keep track of, I guess, basically the individual edges that make up the perimeter for part 2. Um, okay, so that's enough for part 1. Right, part 1 is just the area times the perimeter. Right, we just showed how to calculate area and perimeter pretty easily as part of this BFS. So that's fine. Then part two says, okay, instead of the perimeter, keep track of these sides, uh, which is like, these top four going up count four towards the perimeter, but there's only one side. So I wasn't sure how to do this, but eventually came up with the idea that we should keep track of, for each direction, like where are all the squares with up edges. So in this case, for this R region, these squares and this square all have an up edge. And then my idea is to do a BFS on all of the up squares. And so like because this whole connected region is all up, uh, that's one side. And then this guy will be another region of up that counts as another side. So that's what I'm doing, is like keeping track of like which squares make up the perimeter in each direction. And then we do a BFS, uh, or like basically another region search, but within the perimeter squares for each direction. So if we see, so for every square, like on the perimeter in this direction, if we haven't seen it yet, then that counts as a new side, and then figure out what squares are in this side, um, which is, I don't know, just a super standard BFS, I guess. There's nothing like this code is very similar to this code, except it's simpler. Uh, and you just do that for all four of the directions, and that gives you the number of sides. So like, why is that true? Um, I mean, you can think of this as like like a sort of more manual way to do it is, grab some square we're going up from that square, say this one, and say, okay, well, anything that's sort of connected to the left or the right of that, I don't want to count that. So like, let me extend to my left and right as far as I can. But like, if there was an R over here that was part of the same region, you would not want to count that. So you need to be careful to like not extend over gaps. So you could do that, and that would like let you count this side. Um, so that's effectively what my BFS is doing, I think, except it's sort of automatically doing it in all directions. Like I know that when I'm considering the up direction, I'm never going to actually make a valid move in this BFS up or down. And the reason is that if I could move up from this square to like, we already decided that like up from here was an invalid square, right? Because that's what it means to be on the perimeter for up. And similarly, if down from here was valid, then like this guy would not be in the up perimeter because he would be moving up into another square within his region. So when you do the BFS on the up squares, you're actually only considering left and right. And so the VFS is accomplishing that like manually expand as far to the left and right as possible. And like similarly for all the other three directions, I guess you could think of like rotating them, and then treating them as top. Um, yeah, so I guess this is maybe a nice way to do that like manual edge expansion process. Um, so that gets you all the edges, and then you just multiply area times edges, and that is it. So that's all for today. Kind of a cool part two that required some thinking. Uh, and I placed pretty well on it, so that's nice. Um, yeah, I will see you tomorrow.